Hello folks, Chuck Black here. We are doing 52 weeks of Python. This is going to be week number 12, and we are going to talk about lists versus dictionaries. So you've learned about different Python data structures. Specifically, we've talked about lists and we've talked about dictionaries. Here we're going to do a comparison of the two and explain why you would do one over the other. So that's what we'll be talking about. Before we do that, however, I did want to give you a teaser for what I'm going to talk about at the end. And what I'm going to talk about at the end is this thing that I've been working on that you can see a little bit here on this screen. It's workers. If you've read the documentation, you will know this, but the functionality for doing packet capture, for doing traceroute, and also for doing extended port scan is done by separate applications because they have to run as root, and we can't run that inside the web service, the Flask web service that we do run Quokka in. So those are external, and what I've done is I've made them available to be run on a separate system. And so what you can see here, here's my Windows laptop that I'm running on. That's what this particular Chrome window is for. I have two VMs running. One of them down here is actually the thing that we were just looking at, which is my Quokka VM. Quokka actually happens to be running, as you can see here. It's happily running in the background. And then also I've created another VM with the same virtual machine image, but all I'm doing is I am running my remote workers in it. And you can see I have very low memory utilization. I have, let's see, where's my memory? Here it is. I have 2 gig of RAM. I'm only using 1.1, and that's with running 3 remote workers on it. So you can fit that into something really small, maybe a Raspberry Pi or something in the future. That's what I'll be talking about at the end. For now, at the beginning, we're going to be doing this, which is lists versus dictionaries. So enjoy the lesson. Okay, so let's get started on this lesson, which is where we compare Python lists versus Python dictionaries. So I've written a little code here, and I'm just going to give you a general overview of the code. Then we're going to look at what is the difference between a list and a dictionary. And we're going to actually look at this code in greater detail. But what I'm going to do is I'm going to do create devices. This is that function that we've had around and we've been using for a while, but my number of devices is 254, which may seem a lot, but now my number of subnets is also 254. So I'm actually creating a lot of these devices out there. Over 60,000 of these devices are going to be created. And that's so that we can demonstrate the difference between a list and a dictionary. So right here, I've got a list of devices. What I'm going to then do is over the top of that, I'm going to be creating a devices dictionary, which is going to be indexed by the IP address of devices. We're going to look at exactly what that is, so don't worry, but just understand that there's going to be something called devices dictionary. And then what we're going to do is we're going to allow the user, that'd be me in this case, to enter an IP address. And then I'm going to find that device in the list, and then I'm going to find that device in the dictionary. And then I'm going to do this mathematical calculation where I determine how much faster a dictionary is than a list. And if I was to run this, I'm going to run it right now. So it's running over here. You can see that I've just created everything. Now it's going through and it's doing tabulate in order to get this nice output. You can see if I go up to the very top of this, I can't even get to the very top of it because there's just too many of these things, so I can't see the nice headers, but this is my name, that's the vendor, that's the OS, that's the version, and that's the IP address. So now you can see and you can imagine that my first IP address is 10.0.1.1. My last one is 10.0.254.254. I'm going to type in an IP address that should be very quick and easy to find. 10.0.1.1. And you can see I've printed this out. Let me see if I can make this a little bit easier to read here. I've printed it out. You can see it found it really fast when it was a list. That's in milliseconds, so 0.03 milliseconds. When you look here, you can see finding it as a dictionary, it's not 0.03, it's 0.006 milliseconds. So that is significantly faster. And in fact, I've calculated it that it was 5 times faster. Now let's go to the other end of the extreme. I'm going to say 10.0.254.254. Now, you may or may not know what's going to happen here, but basically we do the calculation. I'm not going to look at the actual values, but I'm going to look at my calculated difference. It was 4,247 times faster using a dictionary than it was doing a list. Now, in our little situation, we have over 50,000 devices, and we're going through the entire list, but it's all in memory, and that's well and good. My comparison is not too time consuming. But in another situation where you have maybe more than these, you can see, okay, well, like if you're doing this a whole bunch of times, it's going to begin to add up. So clearly dictionaries are faster. So let's take a look at why dictionaries are faster. So what I'm going to do is I'm going to pull this up. This is my picture that I tried to draw. When we did create devices, this piece right here is what we created. We created a list, and this list has a bunch of device dictionaries. Now, one of the things I'm going to tell you about is that in Python, everything is an object. You're using a dictionary. In fact, everything in Python, from a dictionary to a list to an integer to a string, these are all separate and independent objects in Python behind the scenes. You don't need to know too much about that, but it is going to become a little bit important when I explain to you how things work when I create a dictionary. What I've done is I've created all of these device objects. This is not object-oriented programming, although object-oriented stuff is happening in the background. You're creating dictionaries. So this thing right here, this name, etc., this device stuff, that is actually a dictionary. In Python's world, behind the scenes, that is an independent object that's sitting out there and is referenceable by Python internally. So it's created all of these things, and we've created a list. And now I have subscript 0 points to the first one, 10.0.1.1, you can see. Index 1 points at the second one, index 2 points at the third one, etc. All the way down to here, 64,516 is this last one that points to it, okay? And that is my list. Now what I did after creating this thing with my create devices, I went and I created a dictionary of exactly the same data. And so my dictionary, I have keys 10.0.1.1, 10.0.1.2, etc. And these point directly to their counterpart objects here. What do I mean when I say that? What I mean when I say that is this. My dictionary and my list are actually pointing at the same object in Python's memory. That object, for our purposes, happens to be a dictionary that is called device, and it has name, IP address, vendor, OS, etc. So I've created a dictionary and I have a list. When I do a find, when I want to find 10.0.0.6, what I have to do if I'm dealing with a list is I have to go to 0, index 0, and say, oh, is this it? And I do a comparison. No, it's not. So I go to number 1 and I say, is that the right IP address? No, etc., until I get down to subscript 5 or index 5. And here I look at the IP address, and the IP address is 10.0.1.6. It's the one that I'm looking for. I return it, and everything is good in that situation. What happens with the dictionary? Well, because these IP addresses are actually the keys in the dictionary, all I have to do is say, I want to look at 10.0.0.6, and Python goes directly to that object. Now, if it's the 6th object, it's not going to be a whole lot of overhead. You might expect it to be like 6 times worse. It's actually worse than that, but it's in the ballpark. But what if I'm going to 10.0.254.254? Well, as you can imagine, that's going to be many, many, many times worse because I have to go through this many times, whereas here I do it directly. And as we saw in our code, it actually turned out to be 4,000 times faster doing it with the dictionary. So that is what this code actually does, and to give you an idea. And if I were to do something in the middle, 10.0.128.128, let's see what happens when I do that. So that was 1270 times faster. Now this, because we're dealing with small amounts of time, it's not going to be super consistent, but what you will see is that it's at least in the ballpark. Well, okay, that one was 3403. Let's do this again. Let's run it. 2059. I think you're getting the general idea. At a gross level, it's much faster to do it as a list than it is to do it as a dictionary. Dictionary is much faster. So let's go and look at what this code does. And here's something I'm going to show you that I haven't done before. Oh, by the way, I did set this up, so if I just hit enter, then it exits. So that's good. We've exited. It's no longer running. When you looked at this, you may have said to yourself, why are these red dots here? What is that all about? Well, that's what I'm going to demonstrate to you next, and that is how to do debugging in PyCharm. So let's look into this code in a little bit more detail. Now, the first thing, I can't remember if I've mentioned this before, but you'll see this a lot in Python scripts or applications. Basically, what this is saying is if the, and this is kind of a standard variable that's available within your Python program, if the name of this thing that is running is main, and once again, this is another special kind of magic constant, and main means this is just the script that I'm running. It's not actually intended to be a Python module with functions in it, but rather it's the main program. And so you'll see this, I can't remember if I used it in all of the situations or not. Probably good programming practice if you think that somebody might try to import a function of yours, and if you don't have this, then when somebody imports the function, it will actually try to execute this, which will have bad effects. So that's what that's all about. So we can kind of ignore that for now because, yes, this is the main program. The first thing that we do is we're going to create devices. Let's look into this code to see what it is all about because I actually did modify it. So I'm going to, on my PyCharm IDE, I'm going to do Control B, and that takes me directly into create devices. Now, when you look at create devices, if you recall before, it used to be a whole lot bigger than this. There was a whole lot of stuff going on. I was choosing random device names. I was assigning an IP address. I was randomly choosing a vendor and an OS, etc. What happened to that? Well, the code that you see here is exactly the same, but the difference, all of that extra code was right here, right in this line. And because I'm using this for doing some extra stuff, I'm creating an extra class that deals with generators. I wanted to make this cleaner and simpler. And so what I did is I created a function called create device, and I'm passing in the actual index. That's what we've gotten from this for loop going through that range, and the subnet index. So I'm going to be using these two variables within it. When I go up here and I do a Control B, here's create device, and basically here's all this stuff which you may think that it looks nice, you may think that it looks kind of ugly. I'm in the ugly camp because it's doing all this if statements, and that's kind of annoying, but that's how we ended up setting up these different values and choosing the different values for what the version was going to be, etc. So that is what create device is, and what's it going to return? It's going to return this thing called device. And device, what is device? It's a dictionary. I set the name of the device, I set the OS, I set the vendor, etc. And then the last thing I do is I set the IP address. And then I return device. So right here is where I call create device. Now I have a device. Remember, I alluded to this before. In Python, everything is an object. This is a dictionary, but it is an entire entity that exists on its own in the Python world under the covers, this thing called that we're pointing at called device right now. And what we're going to do is we're going to append it to this list. So we take this device and we append a pointer to it, to the list. If you recall from the stuff that we were looking at before, that's where we're going to be appending this particular item right here. And then we'll be doing this one and then this one, etc. And when we do an append, then we are setting the list at a particular subscript to point to that value. That's what we've got going on there. And then we return the list. So that's what happens in create devices. So we've looked at that. Now devices is what type of data structure? If you answered list, you are correct. It is a list. Now I alluded to the fact, if you remember that picture that we just looked at, let me pull it up again. We're going to have not only a list pointing at those devices, but we're going to have a dictionary. And the keys in the dictionary, I've chosen to be the IP address because I know I'm going to do a find based on the IP address. So I'm going to now create a dictionary. The way that I do that is I go through in this simple for loop. We've seen this before when we're printing or doing other things. We're going to say for device in devices. So devices is the list. Every iteration through, I will be setting this device variable to point at the device in that list of devices that we have. All right, so that's what we're doing. And then what I'm going to do is we have this thing called devices dictionary, and I'm going to say devices dictionary, and you may or may not recall this. The way that we set values in the dictionary kind of dynamically on the fly is we reference its key. And in this situation, this key is going to be something that is brand new that didn't exist before. It's going to be the IP address of the device. So my device dictionary and this key would be like saying sub 10.0.1.1 for the first one, or 10.0.254.254 for the last one. And it is going to point at device. Now, remember last time we talked about copying and we talked about assignment in Python. And what this is doing, remember the equal sign is assignment. So it's taking devices dictionary at the key device sub IP, and it's pointing it at that device. So what you end up with in our picture is you end up with still this same item that's in memory. Remember, it's an object in memory of Python's memory. And we're just saying 10.0.1.1 dictionary. I want you to point exactly to that thing. So what we're going to see here is that the list and the dictionary for 10.0.1.1 are going to point at exactly the same thing. Now what I'm going to go through is to tabulate. This actually takes quite a long time. And then the bulk of what this does is I have a loop which is going to loop forever. Now I'm pretty sure we've gone over this before. When I say while true, this is saying while, and it evaluates this thing, well, that thing happens to be true, so it's going to just keep doing it over and over and over and over again. The only time that it is going to get out of that is if you enter nothing. So if you say if not IP defined, in other words, if the input that is entered, that's what this is, if the input that you have entered is just a carriage return or a null string or whatever, then it is going to break out of this loop and it's going to finish. And we saw that. This is where we exited when we ran it the last time we eventually exited. Now, if we've entered an IP address, it's going to go through, and here I've got start time, and then I am calculating the search time, how long it takes to find it. And what I'm going to do in the first situation, remember what is devices? Devices is what we got back from create devices. That is a list. So this is my list code. I'm iterating through the list, and I'm going to go through every single item looking to see if the IP address matches the one that I just typed in. And if it matches, then I'm going to say, oh, I found it, and I'm going to print something out, and then I'm going to exit this particular for loop. And as you can see in my example here, 128, 128, for my list, I'm going to print out found it list, and it's going to print the actual one that we found. That was the IP address, 10.0.128.128, and it took it 31 milliseconds. And then I end up doing the same thing in the dictionary and printing out the information as well. But we're going to look at that in just a second. So I calculate it by going through the list. As you can imagine, if I'm looking for 10.0.1.1, because in Python lists are ordered and they stay in the order I put them in, 10.0.1.1 is going to be the very first item in the dictionary. And therefore, as we saw, it's going to go pretty quickly, 0.034, etc. And so it's going to find it the very first time. If I put in the very last thing, 10.0.254.254, that's going to take a whole lot longer than before. You can see 0.03 versus 43.54. And of course, that's going to be a lot quicker. And as you can see, the values are quite small here, 0.006, 0.010, probably not a whole lot of difference in any of these ones where I'm looking for it in the dictionary. So let's look at how we find it with the dictionary. The way that we find it in the dictionary, we don't even have to look. All we have to do is we just have to reference it. So my device is dict. I pass in the IP address. I've immediately found it. I don't really need to actually find it. And I'm going to come down here and I'm going to then print out this information and I'm going to do my little calculation to figure out how much faster it is than not. And that's how we end up with this information that you see right here. Now that's what the code does. What I'm going to show you next is exactly how we can run the debugger and step through this and see what happens. Okay, so let's get our feet wet using the PyCharm debugger. Now a debugger allows you to run your code just like before, except you can step through it a line at a time. You can set breakpoints where you allow it to run and then stop at a particular point, and then you can examine the data at that particular point. How do you invoke the debugger? Well, there's a number of ways. If I right-click on my file that I want to run, I might have been clicking on this before. I can also click debug, and this is the name of the Python module that we're looking at, L09 list versus dicts. Another way to do it is up here in the top right-hand corner. I have, and this is important, make sure that it says the right thing here. You will make mistakes. I still do, where this value is something different. I can have it be a bunch of different things. This happens to be what we're doing right now. I can run it or I can debug it. So what I'm going to do now is I'm going to say debug, and I toggle breakpoints just by clicking in this gutter area here. So I go over here and I click and I say, okay, I've got a breakpoint set. So when I run it, it's actually, if I run it in the debugger, if I debug it, then it's going to stop there. So I'm going to click this and let's see what happens. Okay, wow, so this is interesting. So it's popped up the debug window actually down here. So that's an interesting circumstance. It is not doing it up here on the right as we might have expected. Now, the reason that it's doing that is because I have not moved this output for the debugger and console for my debug session to be over there on the right. How can I do that? Well, you come over here to the gear and you actually have many view modes and you can tell it where to move it to. So I can say what I've done before is I want you to move it to the right top, and what it's going to do is it put it over here on the right just like before. That thing that we were looking at before, that was the run output, and as you can see, that's done. Don't get confused. That's when we did a run beforehand. This is debug. So we're looking at the debug, and now this is different because wait a minute, what is it doing here? Why does it look different? Well, here's the console. This is the output. It's running right now. This is the debugger. I've stopped at this particular point and I haven't executed it. And what I can do is I can look at the various pieces of data that are available and relevant to what I'm doing. Now, I haven't set devices yet. What I'm going to want to do is I'm going to want to run to the next line of code. The way that we do that, these are the three things. Actually, there's 5 of them, but the ones that get used the most are 3. I can step over, which says run this line and then stop when you're done. I can say step into, which would tell Python, tell PyCharm that I want to step down into create devices function, or I can say step out, which is not really relevant here. There's other mechanisms that I can do. But for right now, I'm just going to say step over, which says run to the next line. So what I'm going to do is you can see console. There's this little blinking thing. I can look here. Hopefully this comes through. I'm printing out all these dots as I create this 64,000 list of devices. One thing that you will notice is that things run much slower when you're running them in the debugger, and we're going to see that painfully a little bit later. But it is completed device creation. So now I have created my devices. So that's good, but why is the debugger helpful? Well, let's go back to our debugger window and see what has shown up. Whoa, look at this. Something showed up over here. Let's take a look and see what it is. Devices. This is giving me a little bit of a snapshot of all of my devices. What I want to do is, I know that's a list. Let's open it up and look at this. I have my list of devices, and the index 0 is going to be one particular value. And if I were to look at that, I'm going to make this a little bit bigger. The IP address for that is 10.0.0.1. That's index 0. Index number 1, which is the second item, the IP address is 10.0.1.2. And remember, the thing that this points to, my list, it's a list of dictionaries, and these dictionaries we know are actually individual devices. And let's look at the data here. This curly bracket with a particular thing followed by a colon followed by another thing in a comma. You're familiar with that, and you know that that is actually a dictionary. So here's the beginning of my dictionary, this curly brackets. Here's the end of my dictionary, this curly brackets. So this is showing me this is actually this device. And if I were to scroll down, I would get eventually to the end. I could ask it to list them all. I'm not sure if that would be wise, because there might be too many of them for PyCharm to handle, so I'm not going to do that right now. But now you get the idea. See how wonderful this is? I can see each one of these, and I can expand it or I can collapse it. Now we're right here, so let's go to our next line of code and see what happens. I'm going to step. Now I'm at the beginning of my for loop for device in devices, so what we should expect is that there will appear something called device when we go to the next line. So let's go to the next line, and sure enough, there's device. Let's look at device. That's very nicely displayed for me. I can see the device that I'm looking at right now, the first one. I can see the name, I can see the vendor, I can see the OS, and there's my IP address. That gives me some comfort because I know that that's 10.0.1.1. Now, if I don't want to just step individually, what I can do is I can set a breakpoint at this line. And what I can say is, instead of doing a step, I can say, I want you to run until you hit the next breakpoint. Well, it's going to hit the next breakpoint, I'm sure, in just a second. Let me run it. Okay, now I've got a new device, and it should not surprise you that my device is IP address 10.0.1.2. This is the second one. Let's look at devices dict. Guess what? I have added a device that's from my previous time. I added to my dictionary a key of 10.0.1.1, and that pointed at the first one. I'm at the second one now, and this is where I'm saying devices dictionary, my subscript or my key is device's IP address. What's the device's IP address? My device's IP address is 10.0.1.2. So what we would expect after we execute this next line is that devices dict will have another entry, and it will have a key of 10.0.1.2. And just because we like to step, I'm going to step to the next line. And guess what? There it appeared, 10.0.1.2. And it's showing it to me in blue because it has changed since the last line that I looked at. Now we're going to let this run until it gets to all 64,000. So I'm creating this dictionary. So let's just let it run and see how long this takes. By the way, creating a dictionary often has a higher cost at the very beginning, but as we saw, by like 5 times to 4,000 times, it's way faster once you have created it. So let me let this run. I'm going to get rid of this breakpoint by clicking on it. I'm just going to say run. It's going to go through that, and look at that. In just a couple of seconds, it has completed creating that dictionary. And now that dictionary actually is filled with all of these items. We're not going to look at all of those. So, very good. Now the next thing that we're going to do, and I printed this out, is I'm going to print out calculating tabular output of devices, because running tabulate in PyCharm debugger is actually going to take more than a minute in order to do this. So I'm going to let it run, and I will speed up the time so that you don't have to sit through the whole thing, but we will see what happens. So I'm just going to step. Now, if I look in the console, I should see, okay, there, I've seen that I'm calculating number of devices. That's this line. And now we're going to just do a print where we're calling tabulate. And remember, I said this would take a while. I'm going to do a step so that it ends up being done. I will warn you that when I ran this the first time in the debugger, I actually thought that it was broken. So bear with me, but I will make it go way faster for you when I edit the video. And we're back. Okay, so we have actually, that took a little bit over a minute. You didn't have to wait for the whole thing. But now we are at the code that actually does stuff. And you can see we printed it out here. Here's the nice output of all of those 64,000 devices. Now what I'm going to do is I'm just going to step through these line by line, and we're going to look at what these values end up being. I need to be at my console here, because I'm going to ask myself a question, and the question that I'm going to ask is right here, what IP address do you want me to find? I'm going to do 10.0.1.1 and hit enter. And now we should expect IP to find would be 10.0.1.1. Notice, if you saw it really quick, when I hovered over it, then the value, it actually shows me the value. That's kind of handy. If I wanted to look at it in the debugger, IP defined 10.0.1.1. Now let's just step through in this code and see what happens. I'm going to set my start time. Now my times are going to be all messed up because I'm going to be delaying in the middle of this, right? And going slowly as I step through it piece by piece. So we're not going to worry about time too much in this particular instance. So now I'm going to go through all of the devices or until I do this break. And what I'm going to do is I'm going to say if the IP address is equal to IP to find. So let's go actually look and see this in action. Device IP, let's look at device IP 10.0.1.1, and IP defined is 10.0.1.1. So this should be true. So let's step through here, and lo and behold, yes, it is true. So I'm going to print out the device, I'm going to calculate the search time, and then I'm going to print it out, and I'm going to print out the ID of the device. Now, why is that going to be important? Well, you'll see why in just a minute. You don't have to memorize that unless you're a savant or something like that, but we will look at this in just a minute. All right, so let's continue through here. We found that. Now we're going to do the same thing with the devices dictionary. And as I step through here, all I have to do is say if IP to find is in devices dictionary. So I'm asking it, is 10.0.1.1 a key in the devices dictionary? So it will only go through and do this if the key is there. And if it is, I'm going to print that I found it. And then I'm going to do the time, and then I'm going to print that out. And then I'm going to print out the ID again. Now the ID, let's look at it really quick before we get to that. Let's see my output here. So now we can look at it. The thing that I wanted you to see is this. When I did the list, the item that I found was located. This is an internal memory location. The ID is like an internal memory location. Think of it in that way. And that's what the value is. When I found it in the list, it was that value. When I found it in the dictionary, guess what? The value is exactly the same. 139748135122240. It's exactly the same. So it found the exact same piece of data. Remember when I was showing you this picture and I said everything's an object when it's in memory? You don't have to worry about that, but behind the scenes, Python is creating this object in memory, and 0 in the list is going to point at it. And in the dictionary, the key at 10.0.1.1 is pointing at exactly the same thing. See, that's what those little arrows are indicating here. So it's pointing at the exact same piece of data. I'm not really using up much more data except for all of these keys. That's not really a big deal. And I've actually found it. And so now I'm stepping through this, I can continue to step through it. If I want to just pause right here at my conclusion, then what I can do is this. I can say run. And what it's going to do is it's asking me for this information. By the way, just so you know, sometimes the PyCharm console doesn't print as nicely as the real console, or if you were to run this in a terminal window. So when you see this, you can actually see, why isn't it printing out this information? Enter IP address to find. That's just something that PyCharm happens. I've seen that happen for the last couple of years, and so I just end up not worrying about it. Now I'm going to do my 254.254 if I've typed that in correctly. And you can see, here we go, I found it. Notice I let it run this time. The time that it took is actually 724 milliseconds. That's because we're running in the debugger and things take longer. And in our dictionary, it actually went way faster. So doing things in the debugger is going to take way longer. But here's the important thing, or at least one important thing. Look at the item. It's pointing at exactly the same item. Both the list and the dictionary are pointing at the same item. If I step to the next line, here's my conclusion. In the debugger, it actually was 15,000 times faster to do the dictionary than the list search. So hopefully in this little example, it has shown you this is why we would use a dictionary. There is a little bit more upfront cost as you go through and you create this dictionary over here where you walk through and create the pointers. I could have done this in my create devices where I return both a dictionary and a list. So if you would know what I'm talking about here, in my create devices, I could have created my dictionary and a list and returned 2 items. That would have been a possibility too. So you don't always have to do it after the fact like I did here. I did it after the fact. You can do it as you make that request, but I just wanted to make sure you understood things were a little bit separate, but it's pointing at exactly the same device as evidenced by this identifier. So yeah, I get people asking me, well, why would I use a dictionary rather than a list? That's probably the main reason. You end up just being able to randomly access specific items exactly when you use something like a dictionary in order to get at the data rather than having to go through one at a time in a list. Hopefully that makes sense to you and you now have a better idea of when and why you would use a dictionary rather than a list. Okay, so that does it for the lesson. What I wanted to do at the closing part here is just show you a little bit of what I'm working on with Quokka. Now I've created this new screen called workers, and I have my various workers. If you read the documentation, you'll know that the workers are responsible for doing packet capture, traceroute, and extended port scan. And I have the local one that's not running, and I have a remote one. So I actually created a separate VM that's very small. You can see here it only has 2 gig of RAM. It's running Ubuntu. It's actually exactly the same VM as your Quokka VM, but all I'm going to be doing on this particular VM is running the workers. And this is a Yoga laptop that I'm running on, so for lack of a better name, I just called it Yoga laptop. I probably should have called it special VM or whatever. But that's what that is. So what I'm going to do is I'm going to run the workers. Now, if you've also read the documentation, you know you can run things independently. So I'm going to just say run workers. And what you should see is that these workers are going to begin to do heartbeats. If you look over here, this is my Quokka VM that's running. It received a heartbeat. You can see that received heartbeat. It looks like I'm not printing out the name of it, but the host name, but I do have the serial number that I have. That's probably something I need to fix. But I have the serial number. That is actually the serial number. Let's see, in my workers, do I show that? I don't show the serial number. Another thing I should probably add here would be the serial number. But in the time that I've been blathering on, you can see that these actually, the status changed from red to green. And so what I've done is I have actually, there's a fair amount of configuration to make your remote workers be responsible for certain parts of the network. And I'm not going to go into that right now. But what I just wanted to show you is this. If I was to do something like go to my services and let's say I wanted to run a trace route, I'm going to move this a little bit over to the side here so that you can see what's going on. I'm going to do a trace route to this DNS service via Google, and what you should see is right here we've received the message, and now we've actually done the trace route, and you can see, lo and behold, on my user interface it's made it both into the database, but in the user interface it's actually made it to the user interface. As I mentioned, these remote workers work for doing packet capture and for doing port scan, which is relevant, extended port scan for hosts, and then for doing traceroute, which is more specific to devices or more relevant, at least in my network, for devices and services. I found out yesterday that my port scan isn't working for some way. If for some reason, if we were to do that, then I think you would probably see an error here. So that's something that I'm working on. But I just thought I'd let you know this is something that will be coming down the pike in the not too distant future. This remote worker capability, I will, when I release it, explain about the configuration, because while it's not super complicated, it's way more difficult than typing in run-all to your terminal screen. So that's for remote workers. Hope you enjoy it when it gets here, hopefully in the next release of the Quokka VM. And until then, talk to you later.